All right, we're going to continue our tutorials with MassFx. From here on out, we're actually going to have the MassFx toolbar docked so that it's not in our way. The way we're going to do that, remember in our first tutorial we talked about right-clicking here, coming down to our MassFx tutorial to turn it on. In order to dock it, all we're going to do is drag it and we're going to drop it up in here. And it will stay here instead of being in our way down here on the left-hand side. So in this tutorial, we're going to look at the multi-object editor. In order to do that, we need to put a few things in our scene. So we're going to start with a plane, and we're also going to add a box. I'm going to give that box a different color, and we're going to use a sphere. We're going to make sure our sphere and our box are picked up off of the plane. All right, so we're going to open up the multi-object editor, and right now it's telling us that we have nothing selected because these objects don't have a rigid body applied to them. So we're going to real quickly add a rigid body to both of these, and it's going to be a dynamic rigid body. And as soon as we do that, we can see we get all kinds of options here. We're going to look at these things one at a time. The first thing we come to is the rigid body type. So I put a dynamic rigid body on both of these objects. But when I select this, I can come down to the drop down and actually change the type of rigid body that the objects have. When we have it under Kinematic rigid body type, it gives us this option until frame. So what we can do with this is we can make this a kinematic rigid body until a certain frame. So if we want the sphere to collide with this plane and collide as a kinematic rigid body, but as soon as it passes through, turn into something else, we can have it do that. So we would do that until frame 50, clicking on that box there, and setting that to 50. All right, in order to show how this works, I've pulled up the brick wall we used in one of the other tutorials, and I put a sphere in the scene. What I'm going to do is I'm going to keyframe this ball kind of shooting through this wall. So we'll do that with auto key, and I'll key it where it's at. We'll go to keyframe 100, and we'll just go straight through the wall at some kind of, well, a little bit of an angle. We'll go at an angle through the wall, and we'll key it there. So basically we just got a straight line going through the brick wall. So now if we set it here, we'll just click simulate so we can see what's happening. The ball's going through the wall. The wall's breaking apart a little bit, and it's going at a constant rate. So we need to make sure we turn auto key off when we do this. So we're going to scrub this and see where it hits the wall. So it looks like it's going to be in the wall at about, we'll use 24 for this example. And we're going to check this until frame. Now, at first glance, when we do this, it may be hard to see what's going on. But if you look real close to the ball actually slows down once it hits the wall now. And we have another tool that's going to allow us to see what's happening. So I'm going to turn this off. We'll go back to 0. And we're going to open up one of the tools we looked at in tutorial 2, which is the Explore Scene. And I've just dragged this out a little bit so you can see more of what's going on. We're going to come down to our sphere. We're going to click on Trajectory, this checkbox right here. When we do this, we get this line in our scene that shows the path that the sphere is going to take. Now, remember that we have turned off until frame. So this is just working as a straight kinematic rigid body. We're going to simulate that, and notice the ball follows this path and everything stays the same. If we reset this and turn our until frame on, and we're going to resimulate this, and this time watch the sphere in this path. So as the sphere goes, the path stays the same, but now that the sphere has hit the wall, it gets shorter, so we can see that it's actually slowing down. All right, so we'll go back to our other scene, and we have the option for baking here, which is the same as if we baked it back here in our simulation tools. We can set up use high velocity collisions, which is by default turned on. And what this does is it provides us with continuous collision detection when we're simulating and baking. So when we have objects that are traveling very fast, and sometimes they're traveling a very long distance in our scene, sometimes the collision detections won't pick that up. And what this does is this allows us to set our collision detection so that they'll pick up this movement, distance and speed wise. Now, in order to show you start in sleep mode, I've come back to our brick wall example, and what I'm going to do is I'm going to select several rows of bricks, and I'm going to make the spaces in between these bricks a little bit more. Now remember, we have dynamic rigid bodies on these, and I'm going to go over to our gravity, and we're going to add some gravity into the scene. Put 1. Actually, we're going to set it to -1, and we're going to hit simulate. Now if you watch our bricks, see our bricks are starting to fall before the ball even hits. So in order to fix that, what we're going to do is we're going to reselect our bricks here, and we'll do start in sleep mode. And now these bricks still can be affected by the sphere. However, they won't actually start moving until something comes in contact with them. So we don't have that drop in the wall like it's collapsing before anything ever happens to it. And back to our new scene, the collide with rigid bodies. All this is saying is that this particular object can collide with other rigid bodies. Under the physical materials, we can set the physical materials of an object, and they have these presets in here. So right now, we'll just play through this simulation, and we'll see our box falls and bounces just a little bit. So what we're going to do is we're going to set the materials of this to preset steel, and we'll run through our simulation again, and we can see we have very little bounce here. We can also manipulate variables here that will allow us to kind of create our own material. So for instance, if we want a real bouncy material, we can turn the bounciness up to 1, and we can see we get a nice bounce out of that. All right, in order to look at the difference between static and dynamic friction, we're going to set up a new scene. I've started the scene with a plane, and we're going to add a sphere, and we're going to pull that sphere up above the plane. And what we're going to do here is actually create a kind of like a bowling alley so that we can knock some things around and see how they react to each other. We're going to create a box, and then we're going to create several cylinders in kind of the layout of a bowling alley. And I'm going to copy the cylinder by hitting shift and dragging it. And then once we get everything the way we want it, we're going to come back here and we're going to apply a kinematic rigid body to the sphere. We're going to apply a static rigid body to the plane because it's not going to move anywhere. For the time being, we're also going to apply a kinematic rigid body to the box and to all of the cylinders that we created. Now with this kinematic rigid body, remember we had this until frame. So what we're going to do is we're actually going to push this ball forward, get it going. And the way we're going to do that is we're going to click on auto key and key. We're going to go to frame about 7. We're going to pull that ball forward and we're going to key it right there. Now we know that 7 is where we stop that motion, so until frame we're going to make it kinematic until frame 6. Make sure we turn our auto key off, and then when we simulate it, it should go forward and keep going. It hit that box there. Now notice that the box didn't move. The reason for that is we need to set up some parameters on that box to allow it to move. Alright, to get it to move, we're actually going to come up here and change it to dynamic rigid body. Again, we still need to make sure that our density doesn't change on us. We're going to take it down to 1 right now. And we're going to simulate it and make sure that it moves. And it does. So now we can change some parameters here and get it to do different things. Now this is where our static and dynamic frictions come into play. So our static friction is going to be the friction that has to be overcome for the box to actually start moving. The dynamic friction is the friction that's going to be applied on the box as it's sliding across the ground. Now, what we have right now in our simulation is kind of like the box on kind of a little slick surface there. We're going to bump the friction up on the box so that we can see it, kind of like if it was on carpet. So let's try static friction about 8. And you can see it actually still moved, but it took a little bit more to get it to move. So we'll bump it all the way up to 1 just so that we can see the difference. And sometimes this, even between 1 and 0.9, make a huge difference in how it moves. Now the dynamic friction, we're going to take that all the way off. So once our box actually gets going, it can slide pretty easily. So notice this time it actually had a really hard time getting it to move because it bounced up in the air there. And if we go the opposite of that, we'll go 0 with our static, 1 with our dynamic. Now it doesn't want to move at all. So now let's take all of the frictions off. Now what we have essentially is kind of like a piece of ice. There's very little friction being placed on either object. And you can see now it bounces all around and actually keeps going until it slides off of the plane. So you can play around with these numbers. Like I said earlier, just a little bit of change in the friction sometimes makes a big difference. And in order for us to get our bowling alley up and running, we're actually going to take these little pins here. We're going to turn those pins to dynamic rigid bodies. And now you can experiment actually with these pins as well. You can change the frictions on the pins and see how they actually react with the box.